Now let's look at some directional valve symbols. Here we can see four symbols that are all pretty much the same. We have got here two-way, two-position valves. So we can see we've got two lines coming in, and we've got two positions that the spool valve can be in, the directional valve can be in. So we've got our spring here in the standby condition. It's holding it so that both lines are shut. So we've got a normally closed valve, but when we activate the valve with our push button, we switch over and flow can travel in both directions. So the top two are normally closed, the bottom two normally open. So in this case, with the spring holding the valve in the deactivated condition, it will allow flow in both directions on our two-way valve. So the key difference between all of them is the actuator. So we've got a push button, we've got a roller here, mechanical roller, we've got an electrical solenoid, and we've got a hydraulic pilot signal that opens, shuts the valve against the spring. Now this one's interesting because you'll see on this one it's got a drain line. So on all spool valves you need to vent the ends of the spool, and that will be done internally, generally to the tank line, but on two-way valves you don't know that one of these is going to be the tank line. In this case it probably has to be. You can only have flow in one direction because you need this to be vented in the right way. Keep an eye on this. Not all designers put this information in because it's not needed, but it is critical, and when you're selecting valves you do need to know this, particularly these two-way, two-position valves. So that's quite key. So let's look at our this next valve, and hopefully you've seen that this now has three ways. It's good to put the port identification on. So we've got a pressure port, a tank port, and an actuator port. It's venting the actuator to return line, to the tank line in the unactivated condition, and then when you activate it, it switches the pressure to the actuator line. So this is a three-way, still two positions. This little thing here, we've got a detent. So as you activate the solenoid, it is held in position. But the key thing on this valve actually is here we'll see the these little poppets. So whereas these are generally spool, directional valves are generally spools, they're not always spool valves, and it will be shown like this if it's a poppet valve, so there will be a reduced leakage from this valve, because spool valves there's always a clearance, so there always will be some leakage between the different ports. And on this one we've now still got three ways, but we've got three positions. So we've got our hydraulic pilot switching from one side or the other, and you can see by the arrows that as it's switched one way, it connects the P line to the actuator line, and on the other way it vents the actuator to the tank return line. So that's our three-way, three-position valve. So let's look at this one. Hopefully now we can all work out straight away what these valves represent, these symbols represent. So we've now got four-way valve. We've got an A and a B line, and we've still got our two positions manually switched. On this one, note here there's no springs. So instead of the springs we've got a double detent here. So the solenoid would switch the valve. It would then be locked in position by the detent, so you can de-energize the valve and save energy. So this is a double detented valve, but again a four-way, two-position valve, and almost as complicated as it gets. These are our traditional C-top valves, industrial valves. So we have got four ways and three positions. The switch the same way all the time. Solenoid operated, pilot operated, again we've got all our standard symbols of operation, but this one actually we've now got a hydraulic pilot symbol here. So we've got external activation. This is a two-stage valve. That can be an internal piloting, so that might not be shown, but this is a two-stage valve. So we've got our solenoid on the top section, which will be a small directional valve, and then to achieve the high flows we need a large valve. So to get that to switch we need hydraulic piloting of that and operation and movement of the spool. And this one symbol indicates that we've got a two-stage valve, so it's a bit more complicated in reality. But actually, another key thing that's interesting to notice here is the center conditions. So this is what's changing on these valves. The actual operating is the same, but the center condition changes on each valve. And this depends, this will be set by the designer, but depends on the type of pump you've got. So if you've got a fixed displacement pump, you need it potentially to be unloaded in the middle condition so that the flow just comes straight through and it doesn't hold full pressure on the pump or damage it. So it depends on the circuit, but all of these are very valid. This one is very common, so we're now venting the A and B lines to tanks. So we're clearing these signals. It's not good. If you've got a valve like this, you don't really know what pressures are going to be occurring here. It might be difficult to predict what's going to occur there. So by venting it to tank, we release the loads off the cylinders. We don't allow the feed through and the leakage through from the pressure or wherever to upset the pressures on these lines. So nice and clean. But an important point to be aware of. So this is our challenge. What do you think these symbols represent? Stop the video and think about it for a few minutes. Start again when you've worked out what this means. So, welcome back. Hopefully, this is a bit of a trick question really, because it looks as though it's a four-way 5-position valve, but that wouldn't make sense. These are actually the crossover conditions. So as the valve switches from center condition to either A or B activated, then the crossover of the lands must form some sort of either closed or open crossover condition. And this is quite critical actually in some cases. If you've got a fixed displacement pump and you switch it and you switch from being open, it's not open in that case, but if it switches from being open to being closed, then you would get an instant pressure spike on that pump, which would damage it. Particularly a gear pump would damage it very quickly. So it is key to know these conditions. Only the designer really needs to worry about it. Once the circuit's fixed, it's not so much of a problem, so they don't get shown on the circuits typically, but they are important to know, and they'll be on the data sheets for the valves, and it's good to recognize what it means as a symbol. So well done if you got that. Now let's go over to our simulation program again and experiment with our valves by switching them and seeing what happens. And remember, you can click on here and you can change your center conditions within the valve to see the effect of the different center conditions. So, and you can blow up this gear pump quite happily, we don't mind that. So again, follow the experiments and experiment yourself to make sure you fully understand the different options that are available. There are lots from our drop down list. So have fun.